This is David Spears, civil engineering instructor at Texas Tech University, talking about CE 3303, mechanics of solids. We're reviewing a recent test. First problem is basically a statics review where we've got a beam, actually a simple frame, fixed at each end, A and D, and has internal hinges at these points B and C along its length. Now, the key to analyzing these things, what we want to know is the reactions at one point, one end or the other, A or D. The key to these frames is to break them up into three separate parts, or in this case three, and analyze each separately, because we don't have enough equations of equilibrium to analyze it all together. So the key is to break it up into parts and put equal and opposite reactions where the parts come together. So starting off on the left end, we'll do a free body diagram of each section, AB, BC, and CD. At A, it's a fixed connection. We have an AY and we have an AX. And then we have a moment, which I'm just going to assume like that direction for MA. Then I'm going to put the loads on it like that. It's really only one load. And to analyze it, I need to get a resultant for that 2 kip per foot load. So it's going to be 2 times 10, or 20 kips. And the thing's 10 feet long, so it's going to be 5 feet from point A, because it's a rectangle. Then I'm going to go to C before I put reactions at B on AB. BC can just be broken apart, and it's really just a hinge at each end, so it's got a BY and a CY. So I'm going to assume those up on BC. And then it could have, load ends up being 0, it could have a BX and a CX. And I put the loads on there. I've got 6 kips, 4 feet from the left end. Then I've got his concentrated moment of 56 kip feet. And that's all the loads I have on there. That is 7 feet to the left of that 6 kip load, and then it's 5 more feet to C. Okay, now I'm going to go down to the right end of D, or to the point D. And it's fixed also at this support. So I've got dy, could have dx, and then I've got md, which I'm just going to arbitrarily assume that way. Okay, now I need to consider the reactions at pins B and C where those members come together. Okay, by Newton's third law, I've got equal and opposite forces. So on AB, I assume BY up on BC, so I'm going to assume it down on AB. And I assume BX to the left, so I'm going to assume it BX to the right on member AB. Similarly, CY I assumed up on BC, so I'm going to assume down CY on CD. CX I assume to the left, to the right on BC, so I'm going to assume to the left on CD. Then I need to put, finally, I need to put my 15 kip load on CD right here at 4 and 6 feet. Now I've got good free body diagrams, so I've got all my support reactions. I've got those internal hinge forces equal and opposite on each member where they come together at B and C. And I'm ready to start analyzing. Now if I look at AB, I've still got 4 unknowns and 3 equations. Turns out, let's say from the get-go, there are no X forces on this entire system. So we're going to say X forces equals 0. Therefore, everything that's an X force on this thing goes away. And therefore, AX is 0, BX is 0, CX is 0, and DX are 0. So there's no X forces, and there's nothing out of a line. If I was to take any moments, any X forces are going to cancel out, zero out through the point, whatever I'm taking the points about, taking the moments about. So now I'm ready to analyze. The only one I can start off with is BC, because it has really 2 unknowns and 2 equations, sum of forces in the Y and the sum of moments. So let's start on BC. Remember BC. I can sum moments about point C. And I'm going to assume counterclockwise is positive for this calculation. I've got 0 is equal to negative BY, negative for rotation because it's trying to rotate clockwise about point C, times 16 feet, the total length of that BC member, plus 6 times 12, the 6 kip force, times the 12-foot distance to C. Then I've got the 56 kip foot moment. It's trying to rotate clockwise, which is negative by my sign assumption. And that's all I've got. So 6 times 12 ends up being 72. Take the negative by to the other side of the equal sign, and I get by positive is equal to 72 minus 56, and divide both sides by 16, of course, to get 1 kip. Positive means up on the member in the way I assumed it. So by, now let me go over here and change colors to blue. By is going to be equal to 1 kip up on BC. Therefore, it's going to be equal to 1 kip down on AB. I could also do sum of forces in the Y direction and solve for CY if I want to look at the other end. So I can go sum of forces in the Y direction equals 0. Positive is up. And I've got by up 1, down 6 for the 6 kip load, negative, and then I've assumed CY up. Therefore, CY is equal to positive 5. And go write that reaction on the free body diagram. So CY works out to be 5 up on that member. CY is down on this member. So now I'm ready to solve for the reactions at either end, at A and at D. So let's go over here and look at A. On AB, I would have sum of forces in the Y, which is really easy. I've got positive is up for this calculation. I've got AY, I've got minus 20, and I got this reaction from BY, minus 1. Therefore, AY equals positive 21 kips up. And I can sum moments about point A. 0 counterclockwise for this calculation is positive. I've got MA minus 20 times minus for the rotation, because 20 is trying to rotate clockwise about point A, minus 1 times 10, this by, times that 10-foot distance. Therefore, this is 100, negative 100, and negative 10. That makes MA equal to positive 110. Positive means what I assumed is correct. Kip feet. I assumed counterclockwise, so that makes that answer counterclockwise for rotation. AY was 21 kips up. Now I can go down at the other end and solve for those on CD. And by the sum of the forces in the Y direction, I've got positive up, I've got negative 5 for CY reaction coming from BC, minus 15 plus DY makes DY equal to 20 positive kips up, therefore the way I assumed it. Some of the moments about D on this member also, CD, counterclockwise is positive. I've got 0 minus is equal to 5 times 10, this total distance 10 feet from C to D. It's positive for clockwise rotation, plus 15 times 6, also trying to rotate counterclockwise, so it's positive, and then minus MD, because that's how I assumed it clockwise. Therefore this is 50 and this is 90, so I get MD is equal to positive, or the way I assumed it, 140 kip feet. And the way I assumed it was clockwise, so that's the way it is. So you see, these things are pretty easy if you break them up into parts, assume equal and opposite forces, and solve for the simple one. Sometimes you have to go back and forth, and it's not quite as easy as this one. But